Ensoftec's HydrologyVA is an engineering tool which provides computations for the different hydrologic methods used in the Commonwealth of Virginia. Chapter 6 of V. Drainage Manual permits frequency analysis using Log Pearson III method to determine peak discharges for drainage areas in excess of 1 square mile provided there is at least 10 years of continuous or synthesized flow records for 10-year discharge estimates and 25 years for 100-year discharge estimates. If the project is located near one of these gauge sites and the gauging record is of sufficient length and time, it is still possible to apply a frequency analysis to that data as follows. If the project is at or very near the gauging site, and is on the same stream and watershed, the discharge for a specific frequency from the flood frequency curve can be used directly. If the project is up or downstream of the gauging site or on a nearby or representative watershed with similar hydrologic characteristics, transposition of frequency discharges can be made, provided the watershed area at the facility site is between 50 and 150% of the watershed area at the gauging site. The U.S. Geological Survey regularly publishes gauge data for the various gauging stations, the most recent one being an annual maximum stages and discharges of selected streams in Virginia. In this video, I shall show you the Log Pearson III Method design module. I click on Log Pearson III Method. This opens the Log Pearson III Method design folder. There are only 2 fields in this folder. A pull-down list of all the established USGS gauging stations with station ID and name. The list of USGS gauging sites are the 582 streamflow gauging stations, for which records are published in annual maximum stages and discharges of selected streams in Virginia through 2007 by the U.S. Geological Survey Open File Report 2009-1007. A SKU coefficient field that can be filled using the SKU coefficient map of the U.S. A question button will show the SKU map for Virginia to help in mirror selecting the appropriate SKU coefficient. Once you select the above 2 fields and click Analyze button, the program opens a new Excel spreadsheet LP3 Calculator XLR. The date and historical annual peak flow data are copied to columns A and B of this spreadsheet. The spreadsheet also contains fields for entering the station name, station ID and the SKU coefficient. You will see that the spreadsheet automatically calculates the peak discharges based on this information. In order to obtain daily streamflow data for the Commonwealth of Virginia from the USGS website, go to http://waterdata.usgov with SW and select Historical Water Data. Next, select Surface Water and Daily Data. Complete the following 3 steps in the spreadsheet. Step 1. Copy water year data column 1 of the spreadsheet to column A row 7, down to the required fields in the spreadsheet. Step 2. Copy stream flow data column 4 of the spreadsheet to columns B and D row 7, down to the required fields in the spreadsheet. Step 3. Sort the data in column D of the spreadsheet from largest discharge to smallest discharge for the total number of values in the data set in this column. The spreadsheet automatically calculates the peak discharges based on the above information. The results can be previewed and printed as PDF file or sent to printer. If the SKU coefficient is incorrect, the discharge table may show NA values for the lookup fields. This is corrected by varying the SKU coefficient values in the yellow highlighted cell. V. Drainage Manual outlines procedures for transposition of design discharges from one basin to another basin with similar hydrologic characteristics. Thus, the design discharge for an ungauged watershed is a direct ratio of the corresponding peak discharges for the respective drainage areas raised to a power for the desired flood frequency for nearby gauging stations. Peak discharges for each of the 2 gauge sites are obtained separately using Log Pearson III method. The area adjustment exponent may vary from 0.8 to 1.0. Clicking on Exit will close this folder. This completes the Log Pearson III Method design module.